All right, so our next topic is the word sequence, and we're going to address what a sequence is in a general sense. The mathematical definition of a sequence is any function whose domain is a set of natural numbers, and the terms of the sequence are considered f of 1, f of 2, f of 3. Okay, so in college algebra you learned that you can take x into an equation, evaluate it, and get a y out. Okay, so we say a sequence is when our x's are specifically the numbers 1, 2, 3, 4, etc. The y values that we generate are the actual pattern. Okay, um, and we usually write this in terms of a sub 1, a sub 2, a sub 3. Now this is very fancy speak saying that the first number is the first number is a sub 1. The second number is a sub 2, the third number is a sub 3, all the way out till the nth particular term. Okay, we're going to look at a couple of just formula patterns, look at how we generate these numbers, just kind of emphasize the different characteristics of these terms. Here's our general pattern, our a to the nth, so our general term is n minus 1 over n. Now, n in this case are the natural numbers. So 1, 2, 3, 4, etc. So what I'm going to do is I'm going to evaluate this at 1. So when n is 1, I get 1 minus 1 over 1, right? Well, what is that? That's 0 over 1, so that's just 0. So our first number in this pattern is 0. And then I'm going to generate n equals 2. And so 2 minus 1 over 2, so that's 1/2. So there's our next number. And then n equals 3. So again, just evaluate it at 3. So 3 minus 1 over 3, I get 2/3. N equals 4. So 4 minus 1 over 4. Just jump down here. It's 3/4. 5. Now at this point, do you notice what's going on here? The numerator seems it's going up by 1, and the denominator also seems it's going up by 1. So this would be, let's see, 5 minus 1 over 5, so 4/5. And then for our sixth one, that would be 5/6. Okay, so this particular sequence is 0, 1/2, 2/3, 3/4, 4/5, and 5/6. Now, if I was to graph that, just what would that look like? Okay, so here 1, 2, 3, 4, 5, 6. I'm just going to put a little estimate here. The first number would be 0. The second number would be 1/2. The third number, and this is just an estimate of where 2/3 is, and then 3/4, and then 4/5, and then 5/6. Now, what do you notice is happening? That particular pattern is getting closer and closer to 1. Okay, and so if I asked you what y value we would have when we're looking at the 1,000th term, you would say, well, I might not know the exact fraction, but I know it's going to be really, really, really close to 1. Okay, let's look at another pattern. Negative 1 to the n plus 1 over 2 to the n. Okay, so same deal. We're going to evaluate it at the 6 numbers. So n equals 1, we'll go negative 1 to the 1 plus 1 times 2 over 1. Okay, now 1 plus 1 is 2. So, sorry, I put parentheses around that. And then 2 over 1 is 2. So what is negative 1 squared? Well, that's just positive 1. And positive 1 times 2 is just 2. So the first number in our pattern is the number 2. Okay, do the same thing for n equals 2. N equals 2, we get negative 1 to the 2 plus 1 times 2 over 2. So this would be negative 1 cubed over 1, right? Well, what is negative 1 cubed? That's a negative. Okay, so our second number in the pattern is negative 1. All right, let me talk real quick about this n plus 1, negative 1 to the n plus 1. What does it look like is going to happen here? As I change n to be bigger and bigger, it starts off at 2, then it goes to 3, then it's going to go to 4. Well, what is that physically doing? Okay, that's actually changing the sign in front of the number. This is what's called an alternating sequence. It alternates from positive to negative depending upon what the value of the number is, right? So I can already see that this one right here is supposed to be positive, and I can just worry about what the fraction says. Well, the fraction is 2 over n, so it's positive 2/3. Okay. N equals 4. Again, follow the pattern. We're going to negative. Let's see, a negative 2 over 4, which reduces down to 1/2. N equals 5. We'll get a positive 2/5. And n equals 6, we'll get a negative 2 over 6, so negative 1/3. Okay, and then just a quick sketch of this. I notice we got things bouncing between positives and negatives here. And let's see, I notice the biggest we get is 2, the smallest we get is 1, and 1, 2, 3, 4, 5, 6. Okay, so when n is 1, we were at 2. When n is 2, we're at negative 1. And then we're at 2/3. And then we're at negative 1/2. And then 2/5 and negative 1/3. Okay, now what do you notice is happening? Right, it's bouncing up and down around what value? Around 0. Right, sort of oscillating is another math term that we would use. So this particular term is oscillating around 0. So if I asked you, what's the value of this pattern at the 1,000th position, you would say, I might not know the exact fraction, but I know it's going to be really, really close to 0. Okay, let's look at one more, just a general sequence. We got n is even, we get n is odd, we get 1 over n. Well, let's see, n is 1. 1 is an odd number, so that's 1 over 1, so that's 1. At n equals 2, that's even, so we get 2. N equals 3, that's odd, so we get 1/3. N equals 4 is even, so we get 4. N equals 5 is a fifth. N equals 6 is 6. Okay, so let's take a look at what's happening here. I have to put some larger numbers in my little pattern here. So 1, 2, 3, 4, 5, 6. All right, at 1 we got a 1. At 2 we got a 2, so it goes up, and then it goes to 1/3, and then it goes to 4, and then it goes to a fifth, and then it goes to 6. All right, so it's oscillating, but it's oscillating bigger. In other words, it's not bouncing around a value and getting smaller and smaller and smaller. It's getting larger and larger and larger away. Okay, so if I asked you what number we think this pattern would approach at the 1,000th term, this time we can't say. I mean, obviously 1,000 is an even number, so you could tell me that it's 1,000. But if I just ask you what the pattern's doing in the long run, we wouldn't be able to generalize a particular idea. So this actually is what's called a divergent sequence. Try to spell that a little bit better. Okay, so divergent meaning the pattern gets larger and larger away from a value, and we can't identify in the general case what that pattern is going to approach. Okay, so we're going to try something a little different. We're going to go backwards. I'm going to give you a pattern, and we're going to see if we can identify what the sequence of that pattern is. So start with something not too bad. We have e squared over 2, e cubed over 3, e to the 4th over 4. So what do we notice is happening? I notice that the exponent and the denominator both match, and that they're getting bigger. And it's based on whatever number they are in the pattern. So in this case, our sequence would be e to the n over n. You tell me what n you want, I can tell you what it looks like. Okay, then we have 1 1/3, 1/9, and 1/27. Okay, looking at that pattern, what do we notice? Well, I notice we've got 3 here. I've got 3 squared here. I got 3 cubed here. Okay, 3, 9, 27. They're all powers of 3. And so I have to kind of think for a second, how can I generate the nth term and see if it fits, right? So I could start off with just 1 over 3 to the n. And again, what we're doing is we're doing an inductive reasoning. We're taking specific values and we're trying to come up with a general formula for that. So when I try that, I want to go back and reevaluate it and see if it actually fits. Okay. So when n is 1, I should get 1. Well, when I plug a 1 in here, I actually get 1/3, which 1/3 is in my pattern, but it's not the first number. So something else is going on with that exponent other than just 1 over 3 to the n. Seems like I'm off by 1 factor. So what can I do to the exponent to make it be 1 less than what it currently is? So what if I subtract? Okay, so let's think about that. When n is 1, I get 1 over 3 to the 1 minus 1. Well, 1 minus 1 is 0. And what's any number to the 0th power? That's just 1. Well, that works. That fits our pattern exactly. What about when n is 2? So we get 2 minus 1. 2 minus 1 is 1 over 3 to the first, which is 1/3. And that fits. Right? So as we keep checking, we find that will generate our whole pattern. So what did we just learn? We just learned go with what we see and check it. When we check it, we might find that we've got a counterexample and we need to reevaluate or readjust our pattern to fit this newfound thing. All right, 1, 3, 5, 7. This is a pretty, I mean, obviously these are odd numbers. Okay, so you got to think, how are we going to generate odd numbers? Maybe you want to take a second and pause it and try taking a guess. Easiest way to do that is 2n minus 1. And let me kind of go back here and convince you of that. So when n is 1, we get 2 times 1 minus 1. When n is 2, I get 2 times 2 minus 1. So that's 4 minus 1, which is 3. Okay, n is 3. Again, just kind of convince you that it does work. So 2 times 3 minus 1 is 5. Okay, so if you want to generate a sequence that gives you odd numbers, 2n minus 1 is pretty much the guy that's going to get the job done. How about 1, 4, 9, 16, 25? Okay, so you want to think, where have I seen that before? What kind of numbers are those? 1, let's see, 1 times 1. 4 is 2 times 2. 9 is 3 times 3. So it looks like we're taking n times n, or n squared. It's good to introduce exponent rules. So as I look at that, I want to double check that. So when n is 1, I get 1 squared. That's 1. n is 2. It works. Okay, so it looks like we've got our pattern of just n squareds. All right, and then this next one. So we got a positive 1, a negative 1/2, a positive 1/3, and negative 1/4. Okay, so we got to think, where have we seen that alternating pattern before? And that was the negative 1n plus 1 bit. And we'll double check that in a moment. What about the other part? Well, it's 1 over 1, 1 over 2, 1 over 3. Well, that's just 1 over n. Okay, so let's double check that. So when I put my first number in, I get negative 1 squared times 1 over 1. Well, negative 1 squared is positive, so I do get 1. Put n equals 2 in, I get negative 1 times 2 plus 1. Times 1/2. Well, that's negative 1 cubed. And negative 1 cubed is in fact negative 1/2. So the pattern looks like it's fine. And I'll let you kind of go back and double check for yourself to make sure you're happy with that.